Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Hello. So in this problem, we know we're using a mass spectrometer, and we know that the charged particle we care about is traveling in a circular path, so that we know we can go and look at the equation we derived in the textbook for the circular path, or the radius of the circular path of a charged particle moving completely perpendicularly to a uniform magnetic field. When we do that, we find that equation, we see it really relates to a ratio of the momentum of the charged particle, its mass times its velocity, divided by its charge and the magnetic field through which it is traveling. And really, that's sort of a measure of the magnetic force acting on this particle. So we see that the radius that the circular path has for a charged particle depends on the ratio of the particle's momentum and how strong the magnetic force is acting on that particle. Now, in particular for this problem, we're not asked about finding the radius of the path that the particle travels on, the circular path that the particle travels on. We know that information. We're actually asked what is the magnitude of the magnetic field that this mass spectrometer uses. So that means we want to take this equation and solve for the magnitude of the magnetic field, because we're given everything else in this problem: the mass of the particle we care about, its speed, and its charge. So when we rearrange this and solve for the magnetic field, we get an equation of the mass of this particle multiplied by its speed, divided by the absolute value of its charge, and the radius of the circular path through which it is traveling. We plug everything in that we're given in this problem. We know the mass of a particular particle of this type is given by 3.06 times 10 to the negative 25 kilograms. Its speed in this mass spectrometer is about 7.2 times 10 to the 2 times 10 to the 3 meters per second. Its charge, it's singly ionized, so it's just one fundamental electronic charge, 1.6 times 10 to the negative 19 coulombs. And we know that the radius of the path it travels is about 10 centimeters, or 0.1 meter. Plugging this into our calculator, we see that the magnitude of the magnetic field is given by 0.137 teslas.